Hello, everyone. This is Cynthia Rabinowitz, and I am going to be talking today about soils. First, I'm just going to do a couple of technical things here to show, there we go, the slide presentation. And we will just start a little slideshow. Okay, so today I'm talking about soil, which is my favorite topic. This is the first of 3 presentations about soil. Each segment will last about 15 to 20 minutes. And in this segment, I will be talking about how soil forms and the various factors that influence the type of soil that forms in any particular location. First, though, I'd like to share why soil is so interesting to me. So let's look at this diagram of the soil ecosystem and the 3 integrated parts that make up soil. First is the biological health of soil, and that is the interplay of roots, microbes, and lots of small creatures that affect the soil ecosystem. Second is the chemical balance of the soil, which we can see in the blue section on the right-hand side. And this refers to the nutrients in the soil and the relative acidity or alkalinity of the soil, which we also call pH. The physical tilth on the left-hand side relates to texture and structure and the functioning of the soil with respect to air and water movement through the soil. So on the outside of this circular diagram, we see animals, people, and plants at the top of the illustration, and the arrows showing how the life of those biological entities, animals, people, and plants, are involved with the soil as well. On the right-hand side, we can see that all kinds of residues and wastes and animal manures come from the plants and animals on the land. On the left-hand side, we see that the actions that people and animals have on the land surface, including cultivation and tillage, digging, driving over the earth and compacting the soil, all has an effect on the physical health and the biological health of the soil, and ultimately the chemical health as well. So drawing also on this information, we can see that soil is really essential for plant growth by providing, first of all, a structural support system to hold the plants upright, and so physical support for the plants, and also the water and nutrients that plants need to grow. Because plants photosynthesize and create energy from the sun, this whole ecosystem revolving around soil is the only way we have life on Earth. So that's really something to think about and underpins everything that I want to convey about soil during the 3 segments of these presentations. In this illustration, we're looking at the average composition of the soil, and we can see that soil is made up of 2 parts. One part is the solid material, and the other part is really negative. It's negative spaces called pore spaces within the soil, within the body of the soil, and the pore spaces allows water and air to move through the soil and provides oxygen and water for the organisms and plants that are living in the soil. So taking another closer look at the solid portion, we can see that 40% of the solids is made up of mineral material, so particles of broken down rock in the form of sand, silt, and clay. And the other 10% is decomposed organic matter, which is very important for the health of the soil. So now I'm going to switch gears and talk about how soil is formed. So there are 5 major factors which interact to create soil: the parent material, the climate, the topography of the land, the organisms and life in and on the soil, and time, how much time has passed. So each of these factors varies from place to place, but we need all 5 of these factors to determine what kind of a soil will develop in any particular place and how quickly the parent material or rocks break down. So let me just, okay, that's right. So when considering parent material, we first have to understand that the northern part of the North American continent was covered with a mile-high ice sheet during the last ice age. As the ice sheets receded about 12,000 years ago, what was left behind was a very rugged landscape with rocks and debris, but no soil and no plants. The kind of rocks that we have in our state, in Connecticut, in which soil has formed, vary across the state. Here we see a large outcropping of granite bedrock. And this is a very common rock found in the upland parts of Connecticut. And in this photograph, we can see greenish gray patches, which is lichen on the rock's surface. So lichen is a primitive organism that can photosynthesize, similar to how plants do. And that provides the lichen with its own energy. So it can live on the relatively barren type of media that rock is. So the lichen is not drawing too much out of the rock. However, the lichen is helping in its own way to break the surface of the rock down over a very long time and help to make mineral particles. So other types of rock that we see in Connecticut can be limestone, which is found in the northwest corner of Litchfield County. And we also have schist, trap rock, and brown sandstone. Those are other forms of parent material that we see. Also, glacial till is a very important type of parent material which we find in the areas that had that ice sheet during the last ice age. So also known as glaciers, those ice sheets were often as much as a mile high. Certainly in Connecticut it was. And the weight and the force of that ice sheet created an enormous amount of pressure on the rocks below in the earth. So glacial till is the term that is used for broken up pieces of rock that ice sheets literally scraped off the bedrock. When the ice sheets melted, and there was a lot of melting and thawing going on all through the last ice age, there was variation, daytime temperatures and seasonal temperatures that caused some freezing and thawing action. And so there was some movement in the ice sheet. And certainly at the end of the ice age, about 12,000 years ago, when the ice sheets finally melted completely away, the glacial till was left on the ground surface, forming very deep mounds of irregular, unsorted material. And these mounds may be as much as 100 feet deep in places, excuse me, and can be seen across our Connecticut landscapes, often being used as agricultural fields. The next factor is climate, which affects how soil forms. The climate of an area, including the temperature regimes and the seasons, the amount of rainfall, affect how quickly the rocks will break down into minute mineral fragments that form particles of soil, which are sand, silt, or clay particles. Here we can see some of the main climatic regions that we find around the United States. They range from the hot, dry, arid, desert-like conditions to the wet, cool wet and warm wet forested areas. The next soil forming factor is topography. Topography is sometimes called relief, and it affects the local temperatures and water movement across the land. Snow may be seen on mountaintops, while in the valleys there may be summer conditions. Likewise, the valleys receive water, which flows down the sloping hillsides, creating different conditions for soil formation in the valleys compared to the steep terrain. In this cross-section of a landscape, we see how slopes vary and are not of uniform steepness. Some areas are flatter or slightly depressed high up on a hillside, creating areas where water may collect. In those areas, water can infiltrate the ground, adding to the groundwater and affecting the way soil forms. Because of these changeable conditions resulting from our glaciated landscape, soil will change in character over relatively short distances across our landscape. Time is very important because time affects how long the soil has been forming, and therefore how much soil is present in any geographical area. Soil in Connecticut is considered to be young soil because it's only about 12,000 years old. That sounds kind of funny, but older than 12,000 years, again, we were covered with the ice sheet, so no soil. Consequently, our soils are not very deep compared to soils in parts of the world that did not experience the ice age and the coverage of ice sheets. In this diagram, on the left is time 0. So no time has passed and there's no soil formation. As we move to the right, time increases, and as we reach the far right of the diagram, we see that the most time has passed and there's the most depth of soil. Lastly, organic matter. Organic matter is extremely important for creating that living soil ecosystem, a healthy living soil that has a great deal of biological and chemical activity going on in it, is what we want for a healthy planet. Healthy plants growing on the soil, and for healthy animals and humans who eat the plants for sustenance. So organic matter comes from the debris of animals and plants. And these are two very common scenes that we are all familiar with in Connecticut. Our forests with a lot of broken branches and twigs and bark flaking off of trees. This debris all breaks down eventually into soil after being worked over by numerous microorganisms, which we will be talking about more in the next segment. On the right, we see piles of leaves that fall every year from trees, and we know how quickly they can decompose and form a wonderful organic leaf mold, which we can use in our own gardens if we want to rake the leaves up and pile them for use. Otherwise, they rot down in the woods and help fortify the health of the forest soils to keep our beautiful big trees healthy and thriving. In this diagram, we see the interplay of these soil forming factors have created layers of soil material, which we call horizons. So the horizontal layers that we see in soil profiles are given names. The topsoil is right under the surface of the soil and has the most organic matter. And as we can see in this diagram, it also is much darker colored. And that's because the organic matter is at its highest content here. As we go deeper into the soil profile, organic matter is reduced. This is because the organic matter for the soil is coming from above. It's coming from the trees and plants and animals. And so the soil forming factors which are working at the soil surface are degrading and decomposing that organic matter, but it takes a long time for the organic matter to be carried down into the deeper parts of the soil profile. And so as you can see, the deeper we get in the soil profile, the lighter colored the material is, and this is because of the reduced amount of organic matter the deeper we go. So these horizons do look markedly different from each other in this particular example. In some soils, the horizons are not as distinguished or distinctive from each other, and they may only have subtle differences. In general, though, unless altered by tilling or grading, the soil closest to the surface of the ground has a higher content of organic matter and therefore a darker color. Now, I've referred to the organisms in the soil a number of times, and these are the final criteria really in soil formation as part of organic matter. Organisms are vital for breaking down the organic matter or waste to create humus. And humus is a highly decomposed and stable result of decomposition. And humus allows the soil to retain nutrients and water and make those available to plants. The soil food web is a term that was coined by a soil scientist called Dr. Elaine Ingham to describe the multitude of life in the soil and the interplay between all soil elements to create a healthy soil. This is the end of part 1 of Know Your Soil. In part 2, I will be exploring the soil food web and the organic functioning of soil in greater detail and how it contributes to a healthy soil and a healthy overall ecosystem for all creatures on the earth. Thank you very much for joining me, and I look forward to having you come back for part 2.